Pivotal's electric vehicle takeoff and landing aircraft, or eVTOL, looks a little different from the rest of the market. It's tiny with just one seat and weighs less than some motorcycles. You don't even need a pilot's license to fly it. It was designed that way on purpose.
We went down the ultralight path because, frankly, it was not as regulated. We could iterate quickly, go through design iterations, test, build, test, build, test, build.
But that advantage comes with trade-offs, limiting power, range, and commercial uses. This is the tech behind eVTOLs. An eVTOL has two main differences from a traditional plane, and it's all in the name. The first is in how it takes off and lands.
You don't need a lot of room to take off or land. For traditional aircrafts, they need a long runway to take off and generate lift on their wings, on their airfoils from getting speed this way. And a VTOL aircraft actually can use the propellers to generate lift in a vertical way.
That's just like a helicopter, but that's where the similarities end.
For a helicopter, so if you lost your main propeller, you basically wouldn't have any power to generate lift on the aircraft. For us, we have 8 propellers on the aircraft, and you could lose any one, and you would still be able to fly the aircraft.
These aircraft are also electric. Pivotal's is powered by 8 huge batteries.
You don't have to worry about all of the maintenance that comes with engine maintenance for a traditional gasoline engine or a diesel engine or even a jet engine. Also far less moving parts from something like a jet engine.
The company also designed it with fewer parts in mind.
Most eVTOL construction that I've reviewed in detail are far, far more complex. And that creates additional cost, it creates additional weight, it creates a challenge for reliability because each of those is a moving part that can fail.
Pivotal says its eVTOL has 12 control surfaces, or the parts that allow a pilot to control how an aircraft flies. 8 of them are the propellers, and the other 4 are these elevons, which provide pitch, roll, and altitude control in the air. Another design choice gets rid of even more moving parts. Once airborne, the entire aircraft tilts to fly forward.
Traditionally, for a lot of electric vertical takeoff and landing aircraft, they will tilt either the wing set or some of the propellers, or they will have propellers that are designed primarily to help you with cruise flight or propellers designed for vertical lift. The tilt aircraft allows us to use the same propellers to provide vertical takeoff and cruise blown lift.
As it takes off, the entire aircraft tilts back, thrusting the pilot from sitting upright to lying flat. Then the pilot can initiate cruise mode, which tilts the aircraft forward so it can move horizontally, up to 63 miles per hour. Pivotal's aircraft don't require a pilot's license to fly because of its FAA ultralight aircraft classification. Prospective pilots take a 2-week training from the company itself, which includes time in a simulator. The Wall Street Journal's auto columnist, Dan Neal, underwent pilot training in September.
It was an investment of actually a couple of weeks of training there at Palo Alto in their offices, much of which I spent being really motion sick.
Still, after the training and with no prior flying experience, he was in the air.
That was a big one.
My confidence level when I got into the machine was such that I could actually have a good time.
It feels that easy because the pilot doesn't have to do most of the flying. The aircraft is largely controlled by the company's software. Takeoff and landing is largely autonomous. Once in the air, the pilot controls speed, direction, and altitude using one of these joysticks.
The thumbstick here lets you go up and down in terms of elevation off the ground. The joystick going up and down allows you to tilt the aircraft.
To control the aircraft's stability, Pivotal software relies on a variety of sensors.
So we have the pitot tubes that allow us to get to the air sensors in the flight electronics, and so those are letting us know what the wind speed and the air pressure is. Inside, behind the pilot, there's actually 3 flight controllers. We have GPS sensors and a variety of other sensors that allow the aircraft to understand where it is in space and what's going on with the environment around it. It's using that information to understand how to change the speed of the propellers or to move the elevons based on what's happening around it. So, for example, the aircraft will keep itself in the same position even when there's high winds or no winds. And so it's using the wind measurements to ensure that it's still holding its location.
Pivotal's eVTOL starts at $190,000. The company has already sold and delivered 5 aircraft in early access. That's ahead of a lot of the industry in the U.S., thanks to the lack of regulation the company faces with an ultralight aircraft. But to qualify for that category, the aircraft, excluding certain safety devices, needs to stay under 254 pounds. With a parachute and flotation devices included, Pivotal's comes to 348 pounds.
We make trade-offs all the time. We have to not put things in the aircraft we'd love to put in. We have to be very choosy about, radios, about beacon lights, navigational lights, or anti-collision lights. We don't have extra airbags or any number of other things that you could enhance the aircraft with to make it even more survivable in the event of a crash landing.
The other big sacrifice? Its range and flight time. The batteries on these eVTOLs can only support around a 20-mile or 20-minute flight.
It's very mission limited because we're trying to squeeze into a 300 and some odd pound weight envelope.
While a 20-minute flight might make sense for a joyride, that poses a significant hurdle for the company's commercial goals, like supporting emergency services. And while the FAA allows ultralight aircraft to fly in uncontrolled airspace, it also bans flying over any congested area. In other words, almost anywhere people live and gather. The company says it expects to have a path to FAA certification for a larger eVTOL in the coming year or two. Pivotal is also evaluating how the aircraft can be used in the military, but it acknowledges significant tweaks would be needed, like making it hybrid instead of just electric. That would increase the aircraft's range.
The number one mission in our mind is contested logistics, and that is having a fleet of aircraft that are capable each of carrying 2,000 pounds or more, 300 miles or more, and can do it with the cargo on board, or can do it with the cargo slung below the aircraft.
But that's a long way away. For now, even recreational pilots, a big part of Pivotal's market, are skeptical.
One thing flyers have said to me by way of pushback, it says, you don't need an airport, but it can't go far enough to take me anywhere I want to go.
But if the company expands beyond the ultralight category, that could change.
What we're doing is we're perfecting a platform that's got some room to scale that will actually become in a different implementation, likely using the same flight computers, many of the same sensors, the same architecture of motors, same overall architecture of the aircraft, a larger type certified aircraft.